bloopers at the end. Okay. Okay. So welcome to the GenBio Podcast. This is our first episode. Name up in the air. But really the purpose of what we want to do here, and, you know, just to kind of kickstart things, is there's so much cool stuff going on in the field of frontier biology here in Austin. I'm Taylor Capito. I'm a startup founder, CEO here in Austin, working on a product that we're calling the BioNet, and we're working on the GenBio Lab virtual R&D stuff, really trying to enable science. And so, like, with me, my mission is that people can live healthier, longer lives, and we can, you know, stop drowning, get our heads above water, and actually start to look up into the wonders of the world, right? And biology's life, right? And so it's such an important part of the equation is understanding how it works. And so with that, one of the wonders of the world is the stars. If you look up into the sky at night, this is like one of the most, you know, we'll say iconic and epic parts of science, especially right now with Inspiration 4 launching and Polaris and all of this. And what you are doing, Eliah, at the University of Austin with astronaut genomes is so cool. So why don't you tell us a little bit about that?
So I'm Eliah Overbey. I'm a professor of bioastronautics at the University of Austin, and my particular research angle is studying how human beings can live on the frontier of space, particularly from the human health aspect and from the genomic resolution. So the first humans I studied were the Inspiration 4 crew. They launched back in 2021, 3-day mission. 90% of the human omics data that's available online to scientific researchers is what I generated during that mission.
That's pretty incredible. That's so cool. Like, when you told me, you're like, I have the largest library of astronaut genomes. I'm like, I want to work with this person, or at least like learn more about what she's doing. This is so cool. Okay, so you gave me some insight into the fact that there is so much that we don't even realize going into prepping a mission, right? In order to like get the astronauts healthy, but also the data quality. Like, explain to me a little bit about what goes on with that, because it was not something I think most of the public knows.
Yeah.
Right? About, you know, we just see pretty rockets take off in the sky, right? So tell me what happens with a launch.
Yeah, so, I mean, first we have to collect pre-flight data from the crew. We need to get a baseline from them. So we want to collect at least 3 times before they go on their flight. And we collect things like blood, urine, saliva, stool, microbiome swabs on their skin. For the Inspiration 4 crew, we actually got skin biopsies as well.
Jeez.
Yeah,
so we got stool, biopsies, biomes. Wow. I had no idea it was that much data. And then the genome. Right?
The genome, yeah. So from the blood data that we collect, we generate whole genome sequencing data, and we look for changes in mutation rates before and after flight that might indicate either mutation from radiation or even, you know, mutations that could be indicative of some type of cancer forming and overtaking the population of cells in the blood.
So I don't know if everyone understands the importance of this. We're talking about backing up our species in space, right? Like creating life out in the solar system outside of Earth, right? And maybe even beyond the solar system in the future. And right now, there's a lot going on in the world, and this could become pretty critical in the future, but also it's just really cool. But if we don't understand how our bodies react to space, and we just travel to space, everyone that goes to space could die. So what you're doing, finding these baselines of the effects of radiation, the genesis of cancer or not, right? Like this very well could make space travel and living in space actually possible. So tell me what some of your goals are. Like, what are you looking to study first? What are some of your hypotheses? I want to hear a little bit about the research you want to do.
Yeah, so we've noticed changes in the human body since early in the astronaut program. There's muscle loss, bone loss. There's changes in vision that astronauts experience. We observe these at the macro level. We don't entirely know yet what's regulating them at the micro level. So are there any things that are changing in the genome that we could have interventions with via genomic medicine to actually change how the genome is being regulated? So for example, If we're looking at a muscle gene, can we upregulate that in order to have stronger muscles in space? Or, if we're taking a lot of radiation damage, can we upregulate different healing mechanisms in the body? And the first step towards being able to control and create these medicines is actually cataloging what's changing during flight. And we actually don't have very much data in that regard.
Yeah, I mean, I think it would be hard to get data from people going to space. I don't think there's a huge population of people going to space. So this is maybe that will change. Right?
It's been changing with the commercial sector. So Inspiration 4 was the first all-civilian crew to go into orbit. Axiom has been sending crews to the space station. Blue Origin has started doing suborbital flights, so has Virgin Galactic. And SpaceX has had their own programs. Started with Inspiration 4. Jared Isaacman, who paid for the Inspiration 4 mission, has now started the Polaris program. Polaris Dawn was one of the missions this summer. And there's another mission, Fram 2, coming up next year, which is going to do the first polar orbit around the world.
I've got it. Okay, so first of all, I did not go to Polaris, but I went to see one of the Starship launches. It was incredible. So cool. But you saw a whole nother side of it. I mean, you got to interact with the astronauts, correct? Tell me a little bit about Polaris and what that was like.
Oh, Polaris. I thought you were going to say Inspiration 4.
Well, Inspiration 4 too. Maybe both of them. Maybe what they were both like, what some of the differences were. I mean, it's just really cool. You don't get to talk to somebody often okay, you got down and dirty with the astronauts. You got stool samples. So it's like, come on, tell me what goes into the takeoff the mission.
One of the things that really impressed me about both of the crews was how dedicated they were to scientific research. I mean, these crews, they're paying, especially Jared Isaacman, they're paying for their own flights. They'll participate in whatever they want to participate in. And it turns out they want to participate in a lot. So the Inspiration 4 crew did a whole suite of scientific experiments when they were in flight. Polaris Dawn, I think, broke that record and achieved even more while they were up there. And so one of the things that stood out to me was that this omics research that we're doing, we were able to do it once with a NASA astronaut, with Scott Kelly, who did it right before he...
And just really briefly, explain omics for the audience really quickly. I mean, I obviously know.
Oh, yeah. So this is studying the molecular resolution of what's happening inside the nucleus. So this is looking at changes in DNA structure. So if you have mutations in DNA, it's also looking at changes in gene expression. So at the RNA level, what's getting produced from your genome, how is that differing? And then at the protein level, even further downstream of that, what sort of different protein abundances are we seeing?
So it's the different measures of how our biology and our at a cellular level is functioning, right? Yeah. And thank you for that. But yeah, continue. I just wanted to give that definition.
Of course, thank you. Scott Kelly was the first astronaut that participated in this suite of measurements. He did it right before he retired from being a NASA astronaut. And he did a full suite of measures. This is where the protocol was first developed, was with Scott Kelly. And his twin, Mark Kelly, was actually the ground control.
Oh, that's one hell of a twin study.
It is, yes.
Okay.
But after that mission concluded, the line of research hasn't been picked up again at the same level of rigor from NASA. They've done one-off studies in a few different directions where they've looked at some findings from the twin study. So they've looked at changes in telomere length, for example, astronauts.
Were there?
Yes.
Oh, wow. What were some of the changes?
Yeah, in a subset of blood cell populations, subset of your T cells, we actually do see telomere elongation during spaceflight.
Elongation? Okay, so for anyone listening, telomere length is an indicator of aging and cellular function. It's a correlation. We don't know if it causes aging, how it's related, but your telomeres protect your DNA structure. Elongation. That's surprising. So this means, if your telomeres are longer, it's actually an indicator of reduced cellular age. So an increased longevity, correct?
So that's how some people have interpreted it.
Yeah, I mean, it's correlationary, right?
Another interpretation is that there are certain forms of cancer that have protective effects on telomere length so that cells can continue producing indefinitely. And so
this is like senescence factors, right? So it's an indicator of increase in senescent cells, and senescent cells are zombie cells in your body. These are cells that should be dead and they don't die. So you should be scared of senescent cells. Okay, go ahead.
Yeah, so I mean, we don't really have the data. We need to do more follow-up studies to figure out exactly what's going on here. Is it a protective effect? Is it a troublesome effect that we can't conclude. We've just noticed now, not only with Scott Kelly, but with other astronauts on the International Space Station who have been there for 6 months, about 6 months and 3 to 6 months in duration, have also observed this lengthening in telomeres.
Wow. So I think you were sharing some different, biological things that you measured and that happened. And I'd love to hear more. But first, what is the one that you noticed that struck you the most or scared you the most about human space travel that you feel like we should focus research on? If there is one, maybe there's not, but if there was, what would that be?
Well, the thing I'm most interested in is radiation damage. I think that's the biggest question mark.
Okay.
People have hypothesized it's everything from, if you want to do a Mars mission, for example, that the Mars mission's effect on your genome would be anything from just the effects of smoking to a total showstopper or anywhere in between, or where people have made predictions. And because the International Space Station, where we've done most of our scientific research, is so close to Earth, it's actually still protected from quite a bit of the background radiation from space. So we don't have great predictors for what radiation is going to do. So the biggest pathway I see moving forward is taking missions further and further out from the ISS. So Polaris Dawn, for example, went further out than the ISS. Inspiration 4 was actually above the ISS as well. So these new mission pathways are opening the door for us to get increased radiation exposures on these missions to actually figure out how this could affect the human body long term.
So we're close then. We're close to getting real data that has some historical trend to it. That's really cool, and you can then start to benchmark it against real, environmental factors.
Yeah, we're closer to taking these missions out further and further, and also getting larger sample sizes.
Okay.
So Scott Kelly was an N=1 study. It was just him in space. He did have a ground control, so some people say N=2, but one guy in space, N=1.
Yeah.
Inspiration 4, N=4. With something like Starship that could launch in the future, we could start to have N=12 or more. And that opens the possibility of actually conducting clinical trials in space.
Wow. Okay. So this is really cool. So this is like the frontier. This is where we can go. We can go to clinical trials in space. We can start to improve. You talked about gene therapies to improve our ability to survive and sustain in space for to be more durable, our bodies to be more durable in space, enabling space travel. I mean, this is where we are right now. This is so cool. What's blocking you? What is the headache that you face today that's making it difficult for you to do your research to make that reality possible?
Well, the pace of missions is one thing. I think that's something that's correcting itself pretty quickly, all things considered. So assuming you have a larger and larger number of people going to space that you can study, the next thing that we want after that would be the ability to translate experimental equipment to space. So it's still really hard to do cell culture in space. There's a project on Earth that we've done called the Encyclopedia of DNA Elements. So this has been this huge initiative to catalog every single functional element of the human genome. We don't have anything like this under the conditions of spaceflight. On Earth, gravity is consistent, radiation is pretty consistent. In space, gravity is different. I mean, you could have moon gravity, you could have Mars gravity, you could have zero gravity.
This has really interesting potential positive consequences for also our understanding of Earth function, just the function of different genes and pathways. Because if they do change under different radiation settings, we might have, and there are mutations associated with that, we might have an idea more of how, genes function down here on Earth.
Yeah.
Which is cool because it's the comparison. It's the compare and contrast, right?
Yeah.
The baseline.
Yeah. So what the ENCODE project's done is they basically have this giant matrix of data where on one axis you have all the different cell types and organoid models. On the other axis, you have all the different omic assays that you can perform. So you have different types of gene expression assays or looking different types of measurements of epigenomics.
We're using ENCODE to actually inform some of the questions that are driving our initial rule set in the BioNet. So that's actually very relevant to me. Yeah. But I had never thought of it from a space versus Earth control context before. So cool.
The space context adds a dimensionality to that matrix where you're varying the effects of gravity, you're varying the amount of radiation species and types of radiation species these different cells are receiving. The issue that we run into when trying to expand this matrix of spaceflight, if you were to fill this in now, I'm currently working on filling this in like with precision, but the way it's generally going to look, I think, once this is complete, is that we have quite a bit of gene expression data. We don't have a lot of epigenomic data, and we don't have a large enough variety of cell types, such as the ENCODE project has. And the reason for this is we haven't been able to develop cell culture modules that can house all of the different types of cells we can grow on Earth that are compatible with the microgravity environment of space. And we haven't had enough space on a station to really replicate these enough to do the full suite of measurements that we would want to do. So when we look at different commercial space station options that are emerging, or at something like Starship, and how can we fit as many cell culture modules as possible in those structures, this opens up the possibility to actually replicate ENCODE, but for space.
Yeah, no, this is fascinating because it's like such an opportunity, and yet getting the data is the challenge. What about, okay, so first, this is really cool. I see every one of the problems that you address. This is also an opportunity for new research and exploration. I think there needs to be awareness to what you're doing. It's so cool. What's your vision long term? And I know it already, but like share this with the audience because it's so cool. Her vision is so cool for what she wants to build.
Yeah, so I joined UATX, and the reason I chose this program was I was really concerned not just with the technology that we need to get people to Mars, but also what sort of people we're going to be sending there. So we need people who are not just very proficient in the technologies and the science that needs to be done, but also have a deep-rooted understanding in what has made these systems so successful on Earth. And UATX has been building a curriculum that balances both of these aspects for every single student. And so what I'm doing at UATX is building an astronaut program where we're going to train students, not just in the science and then the great books and all of these things, but also on skills that they would need if they want to be the people who go to Mars or who go live on a space station and do this work. What are the training programs and the skills they're going to need to develop? I think we can move that away from being solely exclusive to NASA and their astronaut corps and bring that into the university level.
Yeah, you're basically training Starfleet. You're basically creating a university program to train astronauts. Like any teenager in high school listening to this is who you want to go work with. So cool. Yeah, and about UATX. About the University of Austin. I love what you guys are doing. Now, I've said this before, and me being an entrepreneur, I'm, a person who likes to go change things, right? It's on brand with me. But I did not find that much value out of school. I'm not cool enough to have dropped out, so I'm not a dropout. I did go through college, but a lot of the programs are they felt like fluff. They felt like they weren't really useful to me in my life, and I was just going through to get the piece of paper at the end. And I changed majors like 5 times because of it, because I was just taking classes that I thought were cool. Looking back on it now, I look at what UATX is doing, and I think it's so cool because you are building curricula around goals, around vocations. It's almost more like grad school, but grad school meets entrepreneurship. Do you want to talk about that a little bit?
Yeah, absolutely. It is pretty applied. One of the things that UATX has done that's quite novel and unique is that we have something called a Polaris program and the Polaris project that students work on throughout their time there. No affiliation to the Polaris, Jared Isaacman's Polaris program.
Which is kind of ironic, but yes.
Yeah. Happy coincidence. But students throughout their 4 years at UATX, they are tasked with working on some sort of project that is for the greater good of humanity. And so this could be a research project, this could be an entrepreneurship and business development project. But they start ideating these ideas within their first 2 years of the curriculum, and then during years 3 and 4 is when they really buckle down and start to build. And the idea is that by year 4, when they graduate, they've produced something novel and meaningful coming out of undergrad.
Yeah, no, this is so cool. So as an entrepreneur, I'm part of the talent network with UATX because I want to be affiliated with that. I want to be working with the students coming out of that program. I mean, it's so cool. So I did want to, talk about that a little bit here. And we're in a place, Austin, right? Everything, I mean, I'm so excited to be here. I feel like we're at the new frontier, right? I mean, look, like space genomes, right? Astronaut programs, Starfleet, making Starfleet real, basically, training astronauts.
People who are really excited to build compared to other places that I've been.
Yeah. And I mean, this is one of the reasons I'm so excited to start this podcast, because I want to shine light on what's growing here. We live in a world right now that is so doom and gloom. I mean, you can't even go on the internet without seeing we're all going to die. Well, let's change that, right? And I think here that's the mentality that's going on in Austin. It's optimism. You know, I like to say it's the solar punk to San Francisco's cyberpunk, right? Because here it's growing, building, positive future, optimistic future. And so I love it here, and I love the people I'm associated with. But yeah, it's getting kind of the alternative view is pretty dark right now. And I did my first rant on X today, where it's just like some of these issues are nonpartisan. We're talking about getting people to space. Yeah. We're talking about humanity's backup, right? We're unblocking all the things that need to be unblocked to enable us to persist and thrive as a species. First, we have to persist. Like, I got in an argument with somebody last weekend. This person said, we shouldn't travel to space. And I said, why? Well, like, what? Why shouldn't we travel to space? Because the solar systems out there are so pretty, and we might damage one. And I just went, are you kidding me? I said, okay. This was my response. If humanity dies, like if we cease to exist, if humanity dies, who's going to observe the beauty of that solar system? And they didn't have anything to say, because it's true. There's an abundance. There are trillions of stars.
The universe is so vast that to think that if we go to Mars, like the universe is ruined, like we've ruined the solar system, is it's a very doom and gloom mindset.
Yeah, and consciousness is so sparse. I mean, regardless, aliens, not aliens, regardless, it doesn't matter. I mean, the fact that we exist is a wonder. It's
right. And right now we have all of our eggs in one basket.
Yes. And we're I don't think people often take the perspective to think that by our ability to observe the universe, we make it beautiful, right? Like, we're a light in that way, and we need to persist, and we need to survive, and we need to thrive. And this is one of the huge avenues. I mean, we've got two real big problems to get our heads above water on. First, one, let's back up our species in various ways. I mean, if Earth dies, and you hear all these narratives of Earth is dying. Okay, if Earth dies, we better have a safety plan. I mean, my background in technology has taught me the importance of a backup. Right?
Yeah, I mean, it's not that far out you don't have to stretch reality that far to think of situations where this might arise. The geopolitical situation in the world over the past few years has been quite unstable. I've heard nuclear war mentioned by the press multiple times over the past few years. Before that was on the table, we were facing a global pandemic, which we can say, it wasn't as bad as it could have been, but like it could have been much worse.
It could have been, yeah. I mean, it could have been like species obliteration level, right. Or at least close to. And then so there's that. There's like something could happen on Earth, and then you hear the argument. So this same person, go figure, made the argument that Neil deGrasse Tyson said that it would be simpler to fix Earth than to go and try to colonize Mars. Right? Something along those lines was his argument. Not Neil deGrasse Tyson's, this person that I was talking to. And I said, why not do both? Like,
why not do both? But also, I do think colonizing Mars is probably easier than fixing the universe problem. We have a lot of problems.
Fair enough. It depends on where you draw the line. But like, okay, so why did we have to choose one?
We don't.
So this is so we can do both. We can back up humanity, and we can fix Earth. Yeah. So like, let's work on both problems. There's an abundance of problems. There aren't enough people to be solving all the problems in the world, sure. But I mean, Elon wants to go and colonize Mars. let's support Elon colonizing Mars, right? And let's support the people here on Earth trying to fix Earth. And you represent the most beautiful hybrid between the two, because your science, biology, genomes, looking at the comparison between the two. I mean, assuming we have success and we get into space, right, and start living there, right, and other planets, maybe on stations, you're kickstarting a whole wave of the comparison between the two, so we can keep whoever goes up there human, right?
Yeah. So in the order of operations of the way things have been done, historically, a lot of effort has been put into building the rockets and building the space stations and figuring out that technological component. And there's still a lot of work to be done on that front, no doubt, but we've got it to a place where we can sustain humans in space for an extended period of time, and we need to start understanding exactly what's happening to the human body during that time, so that we can actually keep people there for longer and longer periods, so we can actually have colonization class missions. I don't know if this is well known, but typically astronauts are only on the International Space Station for 3 to 6 months.
Okay.
The longest people have been in space is about a year. If you're looking at something like a return mission to Mars, say you don't even want to colonize Mars, you just want to go there for a camping trip and come back, you're looking at 1.5 to 2 year mission, which is longer than any human has been in space to date.
What would you say? What would you say to, like, let's say that we have different people viewing this podcast, and you have parents, you have probably younger kids aspiring, looking up into the stars, wanting to be an astronaut. What would you say to them?
Well, I think now is the right time to get involved in the space sciences and the engineering and the science behind all of this. Because I look at things like AI that have been emerging. And AI is really good at automating things that have been done time and time again. But it's not very good at automating things that haven't been done before. And space is something that we're all figuring out for the first time. There's not very many features of it you can automate yet.
So you're saying that there's an abundance of problems to get involved in, but also a lot of opportunity now that the technologies are reaching that critical mass. I mean, it really is kind of amazing where we are. At any time, people, that you start to get depressed when you look at the news, just remember we're literally in the age of space travel, editing our own DNA to live longer, healthier lives, and AI helping automate the crap that we don't want to do anymore as a species, right? Just reframe, because this is wonderful. Like, we're truly in an age of wonders if we make use of it that way, right? And it's pretty cool. And I want the people that are doing, some of the incredible work that you're doing, Eliah, to succeed. I mean, I want to help you. So why don't we go there? How can, what can people do to help you?
Yeah, well, so right now I'm setting up a research lab at the University of Austin. It's a bioastronautics lab where we're going to be sequencing, we're going to be running it as a sequencing course. We'll be sequencing anything and turning a profit off of that to help fund the astronaut sequencing research that we need to do. So for all of the studies that we did in the Inspiration 4 crew, the way that we produced that 90% of humanomics data that's available now to the scientific community, we did that largely with philanthropy money. Chris Mason raised that money over at Weill Cornell Medicine through the World Quant Organization. The NIH isn't really funding this very well. NASA isn't funding this. NASA has a lot of things to fund, and they face a lot of budget cuts. They're not funding this very well either. So it's mostly come through philanthropy. As we're seeing the number of missions increase year after year, we need other lines of revenue funding the research that we need to do.
So funding the research is an area that, so people, anybody listening, if you want humanity to survive, listen. Okay.
So I'm building that lab at UATX right now. And I'm also hosting an astronaut summit at UATX next month. So from the astronauts that we've been studying before from these commercial missions, we're bringing them back together. We do annual follow-ups on them to see, at the research level, is there anything going on that their doctors might miss in your typical physical? So we do the same sample collections that I mentioned previously. And around this, we're building a program where we'll have the astronauts speaking. We're having other researchers come out and we're doing a big just day of celebration of the achievements of commercial astronauts. So that's November 16th at UATX, and we'll be selling tickets for that soon.
I will be there. I will definitely be there. Chance to talk astronaut, space, science, genomics, all the things I like. Very cool. I mean, I'm in a space suit, and well, it's a fake flight suit, but I just had this, but it was meant to be for this podcast.
You have like 5 of them.
I do have like 5 of them. Okay, I'm gonna put my helmet on and like there. So now I have a helmet. Yep. Okay. So helmet aside. Okay. So this is really truly a call to action, not just for what you're doing, but also really to improve humanity. And again, come to Austin. Anyone who wants to learn more about space, about genomics, come talk to Eliah Overbey. And so with that, thank you for sharing that, Eliah. And I will definitely come. I will be at the summit on the 16th. I'm really excited. What are some of the topics you're going to cover at the summit?
Yeah, so we're going to have 2 different astronaut panels, one with covering this trajectory from what are these personal journeys of astronauts that are going to space now.
You're going to have astronauts at the panel?
Yeah. So far, we're looking at hosting Cyan Proctor and Christopher Szymborski from the Inspiration 4 mission. We're also hosting Victor Hispana and Rob Furl, who've been on Blue Origin missions.
Very cool. So you can come to the summit and meet an astronaut.
Yeah.
Right, okay. Do you have genomes for all these astronauts?
For some of them, we have it sequenced. For others, we're working on it now.
Oh, cool.
Yeah.
Cool. Very, very cool. So you're going to have real live astronauts there, chance to talk to them, chance to learn about them. I often think of as an entrepreneur, the crazy soup of my life that led me to constantly want to literally ram my head against the wall trying to change things all the time, right? It's not a normal input to the system from the environment, right? And yet here I am. Do you have any idea of what goes into that for an astronaut? What makes somebody want to go to space? What makes somebody really want to go to space, right? Do you have any idea on that, or are you gaining any insight?
We do have a panel that's going to be talking about this during the summit. We have Cyan Proctor and Victor Hispana who'll be talking about their personal journeys to space. So Cyan was part of the Inspiration 4 crew. She was a geoscientist before this. She also had pilot training. She applied to be a NASA astronaut and I think was cut very late in the process. So she had an interest in this for a very long time. She'll be there talking about her journey, about what that was like and what got her to Inspiration 4. Victor Hispana was a Blue Origin astronaut who went up a couple years ago. He's Brazil's first private citizen who's gone to space. And so he'll be talking about that journey of how he went from being a civil engineer to becoming this sort of hero in Brazil that's broken boundaries for the rest of the country.
That's so cool. And I loved going to Brazil. Really cool people there. I can't even imagine. There's a lot, the psychology of being up in space. I mean, space is beautiful, but I live in a tall building, and that can be ungrounding, if you will. I'm so curious of what drives somebody, because typically people that go to space, they want to keep going back.
Yeah.
But there's a certain type of person, right? I mean, I'm sure it's also exhilarating. You were telling me some things the other day about some of the people who have been in space the longest. Do we have information on them?
Yeah, so there's Peggy Whitson, who actually has the record for the American who spent the most number of days in space. There's a Russian who spent a bit longer in space, by sheer number of days, but Peggy's the longest American.
What was the Russian?
I don't remember his name.
Okay. Okay, so tell about Peggy.
Yeah, so Peggy had she'd been to the ISS multiple times, and she actually hit the radiation limit to where NASA wouldn't send her anymore. So if you've been in space a certain number of days, you've taken a certain amount of radiation, there's, worry about what this might do to your health.
What's her age?
She, I believe, is currently in her 60s.
Okay. And she's healthy?
And she's healthy, yeah. So she retired from NASA after she hit that radiation limit. As far as I know, she's healthy. She now works for a company called Axiom Space, which is a private company, and they send private crews to the International Space Station. And she's been commander of the Axiom 2 mission, and she's commanding the Axiom 4 mission this December. So she's still going to space. She's just doing it through a private company.
See, this is where we're basically, I would like to see some of the common alleles between astronauts and entrepreneurs, because there seems to be just like this persistence. Makes sense that UATX would be the nexus of that. Okay, so this is cool. I love that space is becoming more private. I love that we're bringing intelligence into it with biological study, like what you're doing, that it truly is. I think we're entering an age where biology and technology are no longer going to be distinguishable, both in a research setting and also in practice. I mean, you see Neuralink as being like chips implanted in the brain, having success. I went and toured the facility. So cool. There's also, I think, the reverse, where we'll start making technology function in a more like biological, almost like analog way, and maybe over time, technology will begin to mimic biology. Will make in silico things that are able to reproduce and be put into chips, right?
Yeah, biology is certainly becoming a larger and larger component of technology. It might still be a subcategory, but I agree that line is being pushed back further and further.
But you would acknowledge that like we're in truly an age where understanding our biology is going to be a differentiator in what we can achieve with technology, correct?
Oh, absolutely.
Yeah, and so with this being the case, I mean, this is why these next frontier, these new like bio tech, deep tech in the case of space travel, right? Use cases are really fascinating to me, particularly because, I mean, you hear people talk about all these new technologies. They're all kind of at a nexus between like what is biological, what is technological anymore, AGI being on people's minds.
Neuralink was an interesting example too, because a lot of people I think about that as being able to control what's happening on a computer screen, which I think is just the first step. At a certain point, you'll be able to start interfacing with the technology around you and extending your reach further out. So say you are on Mars and you have some android that you want to control that's doing the exploring for you. At what point is that a machine that you're controlling versus an extension of your own body?
Yeah, I mean, this is all of these topics are so cool because people fear AI, they fear technology, but really, I mean, throughout the evolution of our species, we've evolved what we can use as tools. And then our species and our societies have had to adapt and evolve and change. And we get to, not have had to. We get to go to the next level. And I see these new technologies, AI in particular, being the next level of tool access, right? So imagine what we can do if human beings, and this, when you think about the abundance out in the solar system and beyond, right? We're not tapping because we haven't been able to scale. We're then taking like one human being and potentially we have the opportunity now to scale the output of that one human being into like 100 maybe, right?
Yeah, well, I'm wondering if we're going to see the return of the Renaissance man or the Renaissance woman, whereas, time has gone on, science has become and technology has become so complicated that you can really only specialize instead of in a breadth of things really deeply in one particular thing. But perhaps with the assistance of AI, you can actually master multiple disciplines in their entirety again.
Yeah, this is so cool. I spent my whole career trying to automate myself because I wanted to do cool things. I wanted to learn. I wanted to grow. We now have that opportunity, right? We have the opportunity to have access. Like, people thought it was cool when we had the opportunity to access information at our fingertips, when the internet became more accessible with search engines like Google. But this is a whole other level. It's structured now. You can gain content in a second. You're talking about then accessing that content in your mind. It scales out what our brains can do. I mean, I think the biggest fear is a loss of autonomy or a loss of identity. But assuming that optimists that we all band together and because the technology is being developed no matter what. Let's just be honest about that. The technology is being developed. I have this argument with people when it comes to gene editing and like genomics in general.
Yeah.
We have genome sequencing technology now. We have gene editing technology now. We have embryo selection technology now. These are all things that people fear, and they're being used. Do we want more or less data? And do we want to know what's going on, or do we just want to pretend it doesn't exist?
The issue, too, is if you say outlaw it in one country, say you're not going to do any sort of embryo selection in country X. Well, if country Y is doing that over time, country Y is going to have an advantage over country X.
Yeah, so we can just, the best that we can do is be informed, right? Which needs data. I mean, this is like why I'm so, this is why I'm starting where I'm starting with GenRAIT, my company, on making the data accessible. The biological data, particularly starting with genome data, because it is the map of biology, right? It's the key for what's possible to express. Like, if we don't make this data accessible and start using it, we could make a huge mistake. Now we have technologies like never before. And if, like, to your point, do we want to be informed on how they're getting used, or do we want to just pretend they don't exist? This is the mentality that you should take people, or I'm not going to tell people what they should do. This is the mentality that I take, right? I take the mentality that we have data and we should make use, or we get to make use of it now in a way that we didn't before, to drive positive outcomes that benefit everyone, because the technology is agnostic the way a sword's agnostic. It's who wields it that matters. And so this is really exciting that people here like yourself are looking to grow and make use of these technologies in such a positive way to improve humanity. So yeah,
I think that has been an issue, is that people have turned away from new technologies instead of thinking about how they can lead to human flourishing. As soon as something becomes possible, it's now within, it's within play, like it's in the state of play at that point. And you can remain ignorant to that, but what's a better approach, I think, is to get out ahead of it and figure out how you can leverage that so that people can actually have more freedom in the lives they want to live and be able to live more meaningful lives.
Yeah, I love that. And it's very Austin. So, with all of this, I guess, like, coming to maybe more of a close on what we've been talking about, I really, I think we've done a couple call to actions. Like, what you feed is what grows in our society, right? This is just reality. So if we feed hate and fear and all of these negative frames, that's what grows. Put your attention on space travel. Be excited. Have wonder. Put your attention on technology. Be excited. Have wonder. We have so much positive going on in humanity right now. So much change that we can bring to the table if we just put our energy there. And so, yeah, anybody who's in Austin who wants to go and see some astronauts, see the possibility of what we can do as a human species if we just come together, come to the summit on November 16th with Dr. Eliah Overbey and, support. And I will be. Elon's stance on the election, is it relevant? How do we feel about it? Is it urgent? Okay, so here's my stance. Elon wants to colonize Mars and get human beings interplanetary, get them backed up and able to access all the potential of technology with Neuralink, make travel here on Earth easier with the Boring Company. And, I have issues with lithium, but what Tesla's doing is super cool. I mean, like we're talking about improving travel on the roads with AI, right? Like, no more wrecks, no more traffic. So it's a really beautiful thing. The theme with Elon is he just wants to improve the system that is humanity. Right. And this is like a theme that I think is undisputable. He wants to improve the system that is humanity. Now, I don't think that in his initial plan, maybe I'm wrong, but I don't think that when he first was ideating all these visions, he thought he was going to go into politics directly or buy Twitter and turn it into X. Maybe he did. Maybe it was all master plan.
I don't think so either, because I think there's a history of him supporting Democrat candidates before this election, like, a few elections before this election.
So this is my point on this then. The things that Elon wanted to do, they were nonpartisan issues. They're not partisan. Help human beings survive. Help humanity and consciousness survive. Help human beings thrive. This was my Twitter rant, or my X rant. I said that I got in a rant on X for the first time ever. This was the rant. Get out of his way. Well, you didn't. So then he had to go buy Twitter and then get involved in politics.
It's been interesting to watch this unfold, because there have been some actually very alarming things that he's brought up. The way that the FAA has been the primary roadblock in him launching Starship.
Oh,
and the sort of tests.
my sister's in Boone, and when the floods, like there was stuff with the FAA with the floods there,
well, the research, I've been reading stories on X, and I feel like there need to be deeper investigations into exactly what's going on here, because I think X is a great place for getting leads, but I want to see the detailed report.
I agreed.
And I've seen reports that he's had to do studies on, what if Starship hits a shark when it hits the water, what if Starship hits a whale, and then I've seen pictures where they've had to test the effects of the sonic booms on how seals behave.
I saw that one.
And I would like more information on substantiating these and telling us exactly what's going on here, because there's a point where we want to make sure the environment's protected, and there's a point where you reach a level of ridiculousness.
Yeah. So I agree wholeheartedly, and some of this seems just like a campaign so we're in a, I talk about this with healthcare, and I've got a funny story here. So I have a case that I just realized that I'm a class action suit against San Jose Regional Medical Center that I just realized hit California Supreme Court. That's my case, because of bad incentive structures being perpetuated where people are not informed about what the cost will be. I got like a $38,000 bill.
No.
That's not what the case is formed around. The case is formed around hidden emergency room fees and just horrible things. And this is with my company GenRAIT, making data accessible in biology, it's very related, because there's two sides of the problem. It's policy and data accessibility. They feed each other, right? And why a clinical trial would take really long, or why diagnostics don't happen earlier. I mean, there's a policy side to this. And you talked about the bureaucracy of it. I mean, there's this equation that we're not balancing well in our current incentive structure, because we're just keeping the existing big players big and fat, and we have the bureaucracy to support, in my opinion, a sick system, monopolies, right? And there's a level, like you said, to where it becomes ridiculous. And I think in the realm of space, that is probably exactly right and exactly the same thing. The incentive is to support unelective bureaucrats maintaining their power, right? And so there are a few things that I think, you asked Ethan about our stance, that I appreciate about what Elon's doing, which is that he's just doing. He's going and getting things done. He's acting. He's getting people in space. And he's doing whatever he has to do to make that reality possible, because he wants humanity to survive, right? And so he's looking at this as a massive equation of, how do I make humanity survive, and getting involved in maintaining free speech, and politics is how he saw it right to do that, right? And so I really appreciate about him that he's doing stuff. Now,
if the FAA really is what's slowing down SpaceX from sending people to Mars, that's a huge issue that needs to be addressed.
Yes. And so there's that with some of the strategies that I use, is that some of these poor incentive structures, so pharma being an example that people talk about a lot, right? they have all of the capital right now, and they're afraid of becoming obsolete, right? So I don't think it's always as intentionally malicious as people think it is.
Right, it's a system that's built up over time, and it's hard to undo bad decisions that were made in the past.
Yes, because I know some really, really wonderful people. Like I know somebody at Johnson & Johnson who's just a wonderful human being and wanting to improve the world, you know? And so I think
there is something to be said for trying to reform the system from the inside.
Yeah, and so the critique that I would give of like becoming super partisan myself, like why, is that you don't want to, I try to take the approach of we all want humanity to survive, right? And we don't, I categorize some people as nihilists.
I really like this example of the healthcare system as well, because that's one thing. I started a nonprofit with Chris Mason and Savi Glow called Bioastra, and one of the things we're doing is re-envisioning healthcare for spaceflight. And one of the reasons we find that so exciting is because it is really a blank slate that we can build up from the ground, where we don't have all of these bad decisions that have perpetuated and are, you know, cemented in the DNA and the structure of how healthcare is done. It's a blank slate.
Yeah, and okay, so like with, you know, on like just on this thought, for me personally, I like to see where we can collaborate. You know, I mean, this is when there's willingness. Right now, things are unfortunately, I don't even want to go into politics. I don't even want to talk too much about it because it's so heated and there's so much hate and so much division.
There's no winning, yeah.
Yeah, it's just like when we really boil down to the core of what's important, I think everybody's on first principles. Like, let's help humanity survive. Let's help humanity persist. And so we have a sick incentive structure. How do we align that incentive structure with positive change? How do we align that incentive structure with growth? Like, and so for me, you know, what I'm trying to do is form relationships within pharma, form relationships within the government and the healthcare system, because I think that there's this nice balance between public and private, between, small startups and large companies, like where large companies, they don't want to die. They want to remain. I mean,
to get anything done at the end of the day, you have to work with people.
And what do they have? They have capital and people and existing data and structures, and the startups bring new, fresh perspective, ideas, and fast-moving pace, right? And the government brings support, policy, right? And I think we forget that there's a beautiful symbiosis there, and a symphony, an orchestra that can happen if we play together. And I think what happens is that instead, we're all fear-mongering and yelling at each other to maintain individual power. Well, like, I guess this is my call to action. People, if this speaks to you, let's work together. Let's work together to improve human lives. I mean, again, first principles, unless you truly are a nihilist and you just hate humanity and you think our species should just die, forget about the little things that you don't like about somebody else. If you believe that they want humanity to survive and you want humanity to survive, I feel like we can all agree on that. And we can then come to a consensus. We can start to work together and start to support where we're compatible, where there's complementarity, right? Like I gave the example with government, startups, big companies, and this like beautiful symbiosis that can happen where they're supporting each other's growth, and nobody has to give up power. I mean, people often talk about Nash equilibrium. We're in a state of distrust right now where there's nobody incentivized to change their behavior to trust. Well, I'm doing it. So anybody want to join me? Then now you have an incentive. So and I thank you, Ethan, for weighing this in. This is a very I guess like beautiful idea that we don't have a healthcare system in space. It's tabula rasa, blank slate. We get to, if we were to create a healthcare system from the ground up, and we get to do that in space, we potentially get to do that in Mars. And I get that there's different environmental constraints, but what would you propose that look like?
Yeah, well, the first step is actually getting functional healthcare in those areas. A lot of the tests that we do on Earth are not even compatible with the spaceflight environment. So our first step is actually translating those. We have a program we're launching called Orbit, which is starting with using space resources to deploy healthcare anywhere on Earth.
Mm-hmm.
So this would be if you have a refugee camp that needs immediate access, or a disaster zone or a war zone that needs immediate healthcare access, how can we leverage something like a Starship or like the Ghost system from Sierra Space, or some of these platforms that use space to rapidly deploy medical resources in under 2 hours anywhere on Earth. And once we start building up these rapidly deployable modules, we can grow from there and figure out what it is people need both on Earth and also in space.
Yep. So I like that. And so it's kind of like starting at these small, it's like A/B testing kind of. It enables A/B testing on the healthcare in space. It's kind of like what you're saying. Do these micro use cases, these functional use cases, and then see what works, and then expand from there, and then bring it back to Earth. I love that.
Right. Yeah. It's breaking down like what your normal doctor visit is, what you're even going in for, taking it to when do you actually need to see a doctor, and what information do you actually need immediately, and growing from there to help make it more applicable to people.
I love that. Upcoming soon, I'm doing a panel in Saudi, and we're talking about healthcare data access. And one big area of healthcare data access is biometrics. One important area is biometrics. They have the CEO of Whoop on there. It's one of the bands that does the biometric monitoring. What do you think the importance of biometrics monitoring is going to be in space in this system?
Yeah, so a lot of the astronauts that are going to space are wearing various biometric data collection methods. So some of them, maybe they're wearing, I don't know if anyone's done Whoop yet, but they've been wearing Apple Watches, they've been wearing hexoskin vests.
Oh, that's cool.
To collect this biometric data. In terms of partnerships that we've been working with, we're still exploring what makes the most sense. We haven't committed to any singular pathway yet, but we've been looking at we've submitted recently to working with ARPA-H to figure out if this is a pathway the NIH and their advanced research project system can explore for deploying healthcare.
Amazing. So the nexus of all of this research, bringing it all together, joining these data types, data sets, that's going to be one of the challenges. And, I know with the summit, you're looking for funding with your lab for a sequencer, right? And
that's step one, yeah. And
again, the genome being the backbone of predictive modeling in biology, right? It's what makes it possible. Without the genome, you're kind of doing correlational analysis.
It's the hardware we're all running, right? Yeah. We have different software, different epigenomics that run on top of that can create individual variation even between twins, but each of us has a set of hardware features that we're running this code off of, and that's what the genome is.
And then all these biometrics, all these other beautiful data types that are now in space and here on Earth already for years, you join that against the genome data, and suddenly you get a real system that can be modeled, and that's how humans function and how life functions. And so what you're doing again is so cool, and I'm really excited to know you, and I'm really excited to go to the summit and learn more. Thank you all for listening. This has been so informative, so wonderful. You're so well knowledgeable on so many topics, and this was fun for me. So thank you so much, Eliah, and we'll now really call it a wrap.
All right. Thank you so much for having me on, Taylor. I hope we can do this again sometime.
Absolutely.
And dig even deeper into all of these, but this has been phenomenal. I love the positive outlook that you're bringing to the tech scene in Austin.
Thank you. Thank you for that.